Well, thank you for sticking around. So in my line of work, which is the study of past climate change, I plot a lot of time series data, and that's necessary to put all this new data in global and regional context to understand the timing and mechanisms of climate change. And these plots are absolutely critical for this field, but it's really, really difficult to do it satisfactorily and to do it efficiently. So for pure Matplotlib, basically our options are to plot everything overlaid, which in some cases like this, where everything is on the same scale, is fine. But what if I have CO2 data, which is in hundreds of parts per million per volume, and oxygen and isotope data, which is in per mils? You can't plot those on the same axes. Another method is to just do lots and lots of twinned axes. So all of these share the same x-axis and have their own y-axis. And you can see that gets busy really fast. And it's also difficult to discern what's going on in the plot space since they're all overlain. So our third option is to just do a grid of plots, but you can see that this also isn't particularly great for our purposes. You can't really see, you can't compare these very well, and it's really visually very busy with all of the extraneous axes, both x and y. So the best plot for our purposes would be something like this, where we just have at the top and bottom the x-axis that they all share, and then each has its own y-axis, and it looks like it's all in one plot space, and it's visually compact. It's easy to make comparisons, and overall it's just highly readable. The problem is that not very many software packages do this. So your options are to either lay out the money for something very expensive like SigmaPlot, or, and I've done this, you can make all these plots individually in Excel and paste them together in Adobe Illustrator or Inkscape. That's not really recommended. It's very difficult to make changes. So in response to this, I have made TrendVis, which is a higher level Matplotlib API that makes plots in this style. So for the rest of this talk, I'll discuss various features of TrendVis as I walk through how exactly I made this plot that you see before you. And the best part is that all of this is available online, so you can go to my GitHub page and fork my repository, or you can download this on PyPy, and all the data is freely available as well. And even better, we can do this in just 21 lines. So when you first import TrendVis, you'll only see 5 items, 2 convenience functions, and 3 classes. Those 3 classes are grid, xgrid, and ygrid. Grid is just a class that holds all the orientation agnostic features. And xgrid and ygrid, they're essentially the same thing, except that in xgrid, the axis they all share in common is the x-axis, and in ygrid, it's the y-axis. Otherwise, they're initialized exactly the same way and have all the same features. Okay, so when you first initialize a TrendVis figure, it doesn't look very special. It's basically just a grid of axes. The magic really happens when we call cleanup grid. So this removes all of the unnecessary axis spines. And it does that by cycling through a couple lists, one that controls the distribution of these y spines, and then one that controls where you see your x-axis spines. And so when you initialize this figure, you can set them to start alternating on the right side. You can have them all on one side. And actually both lists are exposed, so you can have whatever arrangement of axis spines that you please. However, sometimes it's also nice to overlay data sometimes, so we can twin these rows very easily, and we can get rid of those spines easily. And so now we have all of the axes that we need to make this figure. And now we can start plotting data. So since I'm only working with line data, I can use this convenience function, which is really the last vestige of the original version of TrendVis, which was just this really monstrous function that did everything all at once and only made a one-column version of XGrid. So here I've just provided our XGrid, then all of the data, and a few keyword arguments. And this is what we get. So again, you can find all of this data online, and if you want, you can make this figure yourself. Okay, but what if you don't have just line data? Oops. So I like to show this figure, which is actually from my very first publication, which is in press right now. And I've used axes.errorbar, obviously axes.plot, and fill between x. So really, as long as you can access the axes, which TrendVis in total provides 3 methods for doing so, you can do any sort of plot that you like on this TrendVis figure. And I'll talk about how we access those axes as we come up against those features. So this looks terrible. So we need to set some axis limits, and our XGrid class will let us set all the x-axis limits at once. And so now we can look at 2 distinct periods of time, 5 to about 100 to 25,000 years ago, and it looks like 123 to, yes, 123.5 to 142.5 thousand years ago. And the same thing for the y limits. And also, I didn't feel like setting y limits for this particular row, but the standard in the field is to have warm up and cold down. So let's just reverse that one y-axis. Okay, so now you notice that this plot is really starting to look good, but you can't read the axes. It's impossible. So there are 2 features in TrendVis that will greatly improve the readability of your axes. One is just move the spines out of the way of each other. In this call, I've chosen to just move all of the twins out of the way of the original axes. If I didn't have this one right here, I could have just provided twin shift equals 0.45, and they would have all moved to that distance. I could have moved the original axes. TrendVis is really here to help you do whatever you need to do to make this readable, but to make it useful. Okay, and so this is a good first step, but for some curves that have twins, we can't tell which axis goes with which curve, and that's where this next feature comes in, AutoColor spines. So it's a little difficult to see at this point because the spines are still kind of thin, but what this does is that it goes in and looks at the first item plotted on each axis, takes that color, and applies it to both ticks and spines, or ticks or spines, depending on what your needs are. Okay, so at this point we're really taking shape, but we have quite a few axes and quite a lot of formatting that needs to be done. And so TrendVis has several wrappers that will let you get all of this repetitive formatting out of the way in a very efficient manner. So we set the tick numbering, major and minor ticks, the actual tick dimensions, and the spine width. Oops. And start labeling. So here, since TrendVis exposes the matplotlib figure, oops, I can access that and just do an overall title for my figure rather than trying to fiddle with the x-axis labels. Okay. And this was actually a very subtle change, but if I flip back and forth, you can see it. Again, the figure is exposed, so we can adjust the spacing of the subplots, and that actually takes up a lot of that white space and makes it even more readable. Finally, we can start drawing on this figure. Actually, we could have done that earlier. TrendVis strives to be as order agnostic as possible. So really, I could have hung on to all those extra spines right now, until now, and done the cleanup grid afterwards. It's really up to the user how they want to do this. So in this step, I've chosen a kind of a soft division of these x-axes with this cutout feature. I could have chosen a harder division using a frame, which would have drawn boxes around each column of axes. And finally, I draw some bars on each side to highlight these important features. They're actually glacial terminations, so the end of one glacial period going into an interglacial period. And so here we actually see some of these axes accessing methods. So there's get axis, where you actually provide the physical position of the axis. So for axis 0, we provide the row number, which is 0, and the column number, which is by default 0. And we could have also specified if it was a twin or not. The other method is to interrogate the list that TrendVis stores all its axes in. So this goes by row and then column. And of course, to do that, you have to know where in this larger list these twinned axes are if you want to access those. Okay, and the last step, So actually to draw these highlighting bars, TrendVis has to draw them not on the axes, even though we provide these data coordinates, but on the figure itself. So what that means is if you decide that suddenly these x-axis limits were no good, if you change them in a regular matplotlib figure, then suddenly this bar would be out of alignment with your data, with the data that you're trying to highlight. So what TrendVis does, it actually stores these input values that you give it. And every time you go through TrendVis to adjust the axes limits, or really anything that will change how the figure, how the axes are in relation to the figure, it will go back and adjust the parameters of this bar to make it line up with your new axes extents. Okay, and the last part is just labeling both of our glacial terminations. So termination 1, which was the last deglaciation, and termination 2, which was the penultimate termination. And we can just access these axes using our third method, which is just to go through the figure and interrogate this one-dimensional list that the figure keeps. Okay, and we are actually all done with our figure. So TrendVis makes these very readable figures with highly efficient, extremely reusable code. You can get it on, as I've said, GitHub and PyPy. And that's about it.
Any questions, folks?
So I missed where you set up how many columns you want.
Okay. So that was,
Repeat the question.
okay, so the question was, where did I set up how many columns I want? And that was way back in the initialization. So it was the X ratios call. Oops. So a list of length 2 gives me 2 columns, and these are the relative sizes of the columns. And similarly, these are the relative sizes of the rows. And just for reference, they're not directly comparable to the relative sizes of the columns.
I have a quick
Yeah.
question. Oh.
Yeah, do you have these examples or any other examples posted anywhere?
Can you repeat the question?
So the question was, do I have any examples posted anywhere? So I was actually going to submit this to the plotting contest, but there was a mix-up with the deadlines. I missed out on that. But this presentation is actually on my GitHub repository. It's mscross/reveal.js, and it's under the SciPy 2015 branch. So you can go ahead and take a look at all this code and the figures again. And also, my recent paper will have, once it gets published, it has this figure and a couple others that were made with TrendVis.
I had a question about grid lines. Sometimes it's easy to see, you know what I mean? Like so like the A team on the y-axis
Mm-hmm.
to plot a dotted line across. Is that something? In some of the examples, you have the spline away from the graph, so it's kind of hard to track, at least with my eye, where it sits on the y
Yeah.
axis. Is that something you've thought about?
I have, but I haven't really come up with.
Oh, sorry.
Oh. Oh. So.
I remember to the other ones. I'm sorry.
Yeah. So there was a comment that,
Yeah.
especially on these, it can be really difficult to track where this data lines up against some of these y-axes that are far offset. So I haven't really come up with a very good solution for promoting that level of readability. It's something that I'll have to think about.
That's fine. Any other questions?
Explain out the date, time, labels for the x-axis.
Sorry?
Do you have any examples of labels x-axis?
So the question was, do I have any examples of date time labels for the x-axes? I actually don't, because all of my time series data is in thousands of years.
Any further questions? Okay, let's thank Melissa and all the other speakers.